Hello and welcome to the Whirly Bloke channel. Today I'm starting the first part of a detailed step-by-step guide for beginners to get their first FPV quad built and flying. When you first start out with these FPV quads, you've got a choice to buy a ready-built one that just needs a bit of work and setting up, or you can build your own. And even if you start out with something that's ready to fly, you'll probably pretty quickly get the urge to build your own. And building is like an addictive FPV drug once you start. There's a huge learning curve to understand not only the mechanical and aerodynamic stuff, but also the electronics, the firmware, the software, tuning, and how these all interact and affect each other. And this process never stops. Even the guys at the top of the game will still be learning. And that's what makes this such a fantastic hobby, sport, or whatever you want to call it. So in this part one, I'll take you through all the components you'll need to get started to build something like this. You could source them yourself by watching loads of YouTube videos and reading blogs. But the chances are you'll end up with more questions than answers and probably end up ordering the wrong things. We've all done it. But if you head over to Unmanned Tech, they've got a complete kit of parts to get you on the right track. They've made some sensible choices that are great quality and at a keen price for around about £160. But do check out the links in the description for the latest prices. And in this video, I'll take you through step by step on how to build these components from this kit into this quad that's ready to fly. And in part two, I'll cover the flight controller setup with BetaFlight, the transmitter and receiver binding, some essential pre-flight checks, and the maiden flight with some FPV footage. Now, these videos are going to be pretty long and detailed, and the idea is I won't miss out any important steps. There's some parts that are just repeated, and I'll either skip over those or fast forward them. I'll be doing this in two parts, and I'll put chapter links in the description so you can skip around just to see what you need. And along the way, I'll show you some of my top tips for a successful build and how to avoid any gotchas. So here's all the components in the FPV Source quadcopter kit. The TBS Source 1 frame. This is the best quadcopter frame for the price, hands down. And because it's open source, it means it's had a lot of pilots have their say and added plenty of neat features. And again, because it's open source, this frame's been beautifully cut by Unmanned Tech from aviation grade carbon with unidirectional weave layers along the arms, which basically means it's incredibly strong and ideal for brushing off hard crashes. Next, we've got a couple of quality Unmanned Tech branded battery straps, some strong aluminium standoffs to mount the top plate, a pre-soldered XT60 battery connector and wires. There's an FPV Chaos branded 25 to 800 milliwatt VTX with smart audio, a Runcam Robin FPV camera, a Pagoda 2 VTX antenna, and this MMCX to SMA pigtail and a wiring loom. The flight stack is the awesome Diatone Mamba F405 all-in-one, and I've reviewed this before and used it on quite a few builds. You get the FPV Dime 2207 2450 kV motors and a set of Dell Cyclone 5040C propellers. And you get some heat shrink, a non-slip battery pad, and some zip ties to keep all your wiring nice and tidy. Now, Unmanned Tech do swap these for equivalent alternatives when stocks require it, but you can drop them an email if you've got any questions. Also, it's a really good idea to have a multimeter. You don't need anything expensive, but having one really helps and will save you money in the long run. Checking for short circuits with a multimeter is cheaper than watching the smoke of doom billowing out of your latest pride and joy. And it makes tracking down faults just so much easier. The other things you'll need are a suitable RC transmitter, an S-Bus receiver, FPV goggles, a 4S battery and a charger. I'll be using a Taranis X9D transmitter and an FR Sky XM Plus receiver, But the setup for any Taranis radio like the X-Lite or QX7 will be exactly the same. So let's get the frame assembled. This is pretty straightforward. In the bag of bolts you need to find the 4 long ones. Push them through the inner holes in the bottom cross plate, through the arms, and screw them into the captive nuts in the base plate. We're going to use these longer ones to screw the flight stack onto. And once you've done that, use 4 of the shorter bolts in the outer holes to fix everything together. Just nip these up to make a very strong and stiff frame. We'll tighten all these up later. Now you can mount the motors. You'll find a bag of the correct length bolts, a prop nut, and a couple of spare C-clips. These, the FPV branded 2207 2450 kV motors, combined with the Dell Cyclone props, look to be a great choice. They're the right balance of weight, size and power, and they're not going to break the bank. Unmanned Tech have made a great selection here. Some sacrifices have been made, such as a steel shaft and a C-clip to hold the bell, but the C-clip also saves a bit of weight. Well, a bit. But these are easily overlooked when you consider the price of the motor and the performance you're getting. These motors are based on the DYS Sunfan 2207 motors, which are already the most popular 2207 motor currently available. Just bolt the motors on and tighten them into place with a hex driver. Make sure they're nipped up tight, but not over tight. And when you're done, just put some temporary tape in place to stop the wires flopping around while we solder them in place. Next, you can fix the standoffs in place. There's 8 of them and they just bolt into place. Again, there's no need to tighten them up too much just yet. We'll check all the bolts are done up before the maiden flight. Screw the standoffs up to finger tight. There we go, that's the last one going in and it's all looking pretty good. Next up, we'll mount the flight controller stack. And this flight controller is the all-in-one Mamba F405 from Diatone. Now, I've reviewed this before and used it on a few other builds, and it's an excellent choice. It's basically an F4 flight controller with all the features you'd expect, like BetaFlight OSD, MPU 6000 gyro, and black box functionality. It's a really good, solid product that includes a 40 amp 4-in-1 ESC that's proven to be very reliable. Now, this stack needs to be mounted the right way, and this small white arrow on the flight controller PCB should be pointing to the front of the quad. Although this is all bolted together, it's going to be easier to solder the motor wires if we take off the top PCB. So just undo the plastic nuts by hand, and they won't be too tight, and make sure you don't lose any of these plastic nuts and washers. Unplug the ESC connector at the front and carefully remove the flexible noise suppression PCB. This is a recent addition on the Mamba stack and insulates the flight controller from the electrical interference generated by the large current spikes on the ESCs. It's the first time I've seen it, but it looks like a good idea. Now you can remove all the standoffs on the bottom ESC board as well and screw them onto the 4 long bolts sticking up from the base plate on the frame. You can just do these up by hand as tight as you can, no need for any spanners or nut drivers. Because these are plastic parts, they tend not to come loose that easily. That's it, that's the last one going on. Before we bolt this back in the quad, now is a good time to tin all the pads we're going to use. So here's my silicone heat resistant soldering pad, so I don't burn up my nice expensive cutting board. So let's get everything in place. These are the motor pads down each side and the battery connections are at the back. I like to use extra flux while I'm soldering, even though this is flux core solder. It just makes soldering these large pads easier. It's not expensive and I'll leave links in the description where you can get it. And then you can put a bit of flux on the ends of the battery wires as well. If you're not that experienced in soldering, it's a really good idea to practice on some scrap boards and wires. And since this is the first soldering of the day, load up the iron tip with some solder and wipe it clean. It sort of primes it ready for the day and gets rid of all the crud that's built up. Remember, flux is corrosive and designed to clean the metal, so soldering actually solders. So it's not a great idea to leave it on the boards. But this is easy to clean off with some isopropyl alcohol when we've finished. Now you can tin all the pads, and for this size of pad I'd recommend a temperature of around 400 degrees. 300 to 350 is fine for the smaller pads on the flight controller and the thinner wires. When you've done, make sure you haven't bridged any of the pads or got any blobs of solder on the board or any whiskers of wire across the pads. Then you can solder the battery wires and the XT60 onto the board. Make sure they're the right way around. The positive and negative are marked on the PCB. There we go, that's the negative black one going on, nice and tidy. I'm going to do a quick continuity check to make sure I haven't created a short while I was soldering. It's really easy to have a thin whisker of wire just bridging the pads, and it can be really hard to see. You'll see me doing this loads, but I'm uber cautious and I haven't blown anything up for years. This is where a multimeter saves you money in the long run. It really is worth buying one. So that's looking all good. We can mount the ESC back into the frame, but don't bolt it down just yet, just to push the board down onto the standoffs for now. Now measure the motor wires and leave a bit of slack to get them onto the ESC board. It doesn't matter which wire goes to which pad for each motor. Just aim to keep the wires neat and tidy. It's better to have the wires a little bit long and tuck them out of the way when you're finished. Take your time and double check the length before you cut them. And tin the ends of the wires and solder them in place. Again, taking care not to bridge any of the solder pads. So when you snip these off, leave a little bit slack. You don't want to end up cutting them too short. That will ruin your day. And there's no need for wire strippers on this. Just pull the insulation off with your thumbnail. It's really soft silicone. Make sure there's no little whiskers of wire, and then we can tin these. And it's generally a good idea not to solder directly over PCBs. You do get blobs of solder flicking about when you're soldering, and the last thing you want is them dropping on a board and shorting something out. And there's lots of current flowing around on a 40 amp ESC. Take your time when you're doing this and try to keep a steady hand. Not like me. There we go. That's the last wire going on, and we'll clean all that flux off a bit later. So you just need to do the same for the other 3 motors. And this is the last one going on here. There we go. Arrange the motor wires so they can't get caught by the props. It's a good idea to keep the wiring as tidy as you can and out of the way from some vicious props that like cutting into things. We'll do a last tidy up on this before we fire it up though. Then you can slip a piece of heat shrink over the battery wires and fix the low ESR capacitor in the heat shrink and solder it onto the battery pads. These capacitors generally have only their negative wire mark, so make sure it's on the negative black wire. Remember, these are electrolytic capacitors, so they do have polarity. Again, I've put a little bit of extra flux on here to make the soldering a bit easier. And this is the best place to put the low ESR capacitor on an all-in-one ESC. It's there to reduce the noise on the power supply, which you see as interference on your video. I've seen some ready-to-fly quads that mount this on the XT60, which is a total waste of time. You need to get it as near as you can to the source of the noise to suppress the electrical interference squirting out from the battery wires. When it's soldered in, you can shrink it into place and that won't come off anytime soon. Don't apply too much heat, and this is a great thing about using a solder reflow station. You can use it to focus the hot air where you want it. Using a flame or a large heat gun is just a bit random. A bit of a tidy up, and that's starting to look quite nice. I will put a strain release zip tie around the battery cables to stop the solder pads getting ripped off if the battery gets ejected when I crash. There's a couple of convenient slots in the bottom frame. Now you can screw the top plastic standoffs in place to hold down the ESC board. So this is all the soldering on the bottom ESC board, so you can go around with some isopropyl alcohol and clean off all the flux and the residue. While you're doing that, you can check for any shorts or solder blobs. And this gets rid of all that nasty corrosive flux, and it's probably a good idea to wash your hands afterwards as well. Flux is nasty stuff, but it does do its job. A final clean up with a lint-free cloth, and when this dries off it'll be a nice neat finish, and because it's clean you will be able to see if there's any dry joints or solder bridges. So this is looking pretty good now. To be honest, if you were putting this together without having to make a video, it'd take about an hour to get everything built and about 20 minutes to get the radio and BetaFlight set up. If you're new to quad building, don't rush things and allow a few hours, but it's not a difficult thing to do by any means. One last quick check with the multimeter for any shorts across the battery terminals. Yes, I've done it again, and you'll see me do this all the time. And once that's done, you can put the flexible interference PCB back and screw down the flight controller on top. Make sure the white arrow is pointing forward to the front of the quad and the interconnect is connected back up. These are the wires that join the ESC to the flight controller. Just tighten these up by hand. They don't need to be very tight. The silicone soft mount washers just hold them in place. So we're making good progress here. Next up is wiring the VTX, the video transmitter. This is the Unmanned Tech FPV Chaos VTX that's aimed to be a viable alternative to the more expensive TBS Unify or Immersion RC Tramp video transmitters. It can be powered direct off the 4S battery and is switchable between 25, 200, 500 and 800 milliwatts. It only needs power, video in and smart audio connecting, so you can remove the 5V and ground wires that would normally be used to power the camera. We're going to power the camera off the flight controller board because it's nearer to the camera at the front of the quad. Carefully prise the middle two red and black wires out of the connector and cut the connectors off the other end of the cable. You could leave these in place, but they're not needed and it saves any confusion later. Just gently pull them out. Remember, what you're taking out are the plus 5V and ground supply wires that power up the FPV camera, and we're not using those. And just double check you've got the right wires in the right plug slots using the legend on the top of the VTX module. And this is looking good. Got smart audio, which is green, video in, which is yellow, and red and black, plus 5V and ground. If you look on this flight controller top plate, you'll see TX3 and vid marked. That's UART3 and video out. Solder the smart audio green wire to TX3, that's UART3, and the yellow video wire to the VID pad. Remember, smart audio is just a way to switch the VTX channel and power and see what they're set to in the goggles on your on-screen display. More of that later. The FPV Chaos VTX board can take its power from VCC and ground pads down here. That's just the full battery voltage. Again, you can just strip the silicon insulation off with your thumbnail. I've pre-fluxed and tinned the power pads on the flight controller to make things a bit easier. Take your time and watch for solder bridges. That looks good. Tidy up the wiring a bit. Once that's all done, you can get the VTX and the pagoda antenna fixed to the top plate. Attach the antenna to the VTX with the included pigtail and then fix the antenna to the top plate with a couple of the zip ties. Mounting the antenna like this means it's less likely to get damaged if you land upside down, and it's clear of the props. You can fix the VTX in place with a piece of double-sided sticky foam. This top plate now becomes like a separate VTX module that you can easily remove, and all you need to do is unclip the connector and lift it away if you need to get inside the quad for any repairs. And yeah, it's a nice way to do it. It means you can just unplug the connector like this and lift the whole thing off. The FPV camera included in the kit is the Runcam Robin. Again, this is a really good choice that gives pretty good performance without being mega expensive. This just needs 3 wires to connect up: red 5V, black ground and yellow video. Cut the connector off the other end. Make sure it's not the connector that plugs into the camera. And tin the pads on the flight controller and solder the wires on, making sure you've connected them correctly to 5 volts, ground and video. That's red, black and yellow. Fix the camera in the plastic mount and use a couple of the M2 bolts to fix it in place. You don't need to do these up too tight at the moment. Like everything else, we'll check it all later. Next, fix the camera plates inside the slots in the bottom frame. And these fit neatly between the standoffs at the front. It's a bit like the original Wizard frame, to be honest. That's got the first one in. And there we are, we've got the second one in place, and it pulls the plate in nice and secure. The last thing we need to connect is the RC receiver. Now, I recommend using an FrSky XM Plus. It's not included in the kit, but it's probably the best value receiver available and is extremely reliable. And it's a full range receiver with 2 RC antennas, so you get plenty of range. It only needs 3 wires to be connected to the flight controller, plus 5 ground and S-bus. And you've probably got some offcuts of red, black and yellow wire from the VTX or the camera cables that you can use for this. Check the connection info on the flight controller labels and the XM Plus receiver package. Tin the pads and solder them all in place. Leave plenty of slack in the wires to give you some good mounting options. The spare wire length can easily be tucked out of the way later. You can tuck these under here, but don't pull them too tight. And now, before we get the top plate bolted on, it's a really good idea just to double check the wiring's correct. Just check on the legend on the Mamba top plate. And yet again, I'm going to do a final continuity check to make sure there's no shorts between any of the wires I've been soldering. And we can clean all this off with some isopropyl alcohol. Although it's not included in the kit, it's a good idea to get a buzzer and wire it up to the flight controller. These are really easy to get hold of, very cheap and a lifesaver when you can't find the quad in long grass. Also, it'll give various monitor beeps to let you know what's going on in the flight controller and BetaFlight. You can tuck this down behind the camera and hold it in place with another piece of double-sided foam tape. And you stick the buzzer down there out of the way. Now the quad's all wired up and there's no more soldering to do, we need to mount the receiver and fix the antennas in place. But before we do that, and while the receiver's easy to get at, now's a good time to bind it to the radio. So let's get a new model set up on the transmitter and make a start. I'm using this Taranis X9D, but these steps are identical for other Taranis transmitters like the X-Lite or the QX7. So if you scroll down on the menu page, the first empty slot here, long press enter, create model. There we go. And we'll scroll across to quad, hit enter. Now I've got my presets defined, so I can just hit page, but the way this works is it's asking for throttle, which is channel 3, hit page, roll is channel 1, hit page, pitch is channel 2, hit page, and yaw is channel 4, hit page. Ready to go? Yep, we're ready to go. So long press to confirm that. So we've got our model set up, nice and simple. If we press page to go to page 2, and we'll just change the model name. Remember, you can long press to go uppercase. There we go, hit escape. And if you use the plus key to scroll up, and we are going to be binding in D16 mode. So if you scroll down, if you want to, if that's sitting at another value, just hit enter and you can scroll through the various options. But we're on D16 and go down and select bind, and there we go. So this is ready to bind. Let's get our quad. Now to bind this, we need to apply power while we're pressing down this little button here, which is a bit fiddly. And because we're applying power, we need to do some very quick checks to make sure we're not going to blow anything up. Now, you can apply power from an external power source like this, which I've got set up, or you can use a battery. So we're going to do some quick checks just to make sure there are no shorts anywhere on the power leads or anywhere on the board. Now, I can't emphasize this enough. The problem is if you start connecting power without doing these checks, the chances are you're going to blow something up if you've got a little slither of wire between any of your solder joints. And it's just worth doing a quick visual check first, and just do this as often as you like. It really does save you a load of money in the long run. So a quick check that we've got continuity. It's good. First check across the battery terminals. That little beep is just across the capacitor. That's fine. And there's no harm in just checking that you haven't got a short on any of the power connections that you've soldered. So this is for the receiver. Just to check you haven't got a little slither of wire or solder bead or bobble between those things. Check on the camera as well. Which are those two pins? That's all good. And this is the wiring loom that we've got for the VTX. So that's all good. I'm happy that nothing is going to blow up. Now if you want, you can use a smoke stopper, which you can buy. The best ones are the ones with the bulb. You can make those up yourself, and I'll leave a link in the description to where you can make one of those. The ones that use resettable fuses, they're not really worth it. They don't actually respond quick enough. You can still blow something up. So I say you could use a battery, but I'm going to use my power supply simply because it's less fiddly. So let's turn things on. Okay, so plug that in, and I've conveniently got a switch on my power supply, which makes things easier than juggling this lead while you're trying to press that little button on the receiver. So let's put this in bind, back in bind mode, and always select telemetry on, even if this receiver isn't a telemetry enabled receiver. Okay, so press the button and apply some power. And if you look here now, we've got a flashing red LED and a solid green LED. That means it is correctly bound. If you get any other combination of LEDs on there, there's something weird going on. The most likely thing is that you've got a receiver and a transmitter that are using different protocols for EU or international. But this is looking good. The way to check this is to stop bind mode, and we'll turn the power off the quad. And if we turn the power back on, we've now just got a green LED, solid, and there's no red LED. That simply means that this is now bound correctly to the transmitter. Now that's all done, we can get everything buttoned up on here, and we can go and set up the transmitter and BetaFlight. There's a number of ways that we could mount this, but actually I find the best way is to put some heat shrink over here. You could use clear heat shrink. I've never seemed to have got any clear heat shrink, but we'll use this and put some little cutouts in so we can still see the LEDs if we need to. There we go. Let's just get some heat on this. So there we go. Just be careful if you're doing this, but I recommend using clear heat shrink. It is the better way of doing it. So we're going to mount this on these arms. Now take this temporary tape off. I don't like to use this vinyl tape on the finished thing. And we're going to use some of this cable tape. So what we'll do is just wrap that around there. Like that. And then we can put a cable tie on here, that way up. Just cut these off, to maximum length for the minute, and we'll trim them down in a second. So the receiver I'm going to tuck down underneath this board. If you want to, you can put some double-sided tape on there. Personally, I don't think it's needed. That's not going to move anywhere. Okay, that's fairly neat. The main thing is to make sure that everything is tucked out of the way. It's not going to catch in any props. And what we're going to do is just put a piece of heat shrink over like that. That looks like it's a reasonable sort of length. Now the thing you've got to be careful of is the length of these wires doesn't really matter. This is the bit you need to be very careful of. Don't damage that or cut it short. So if we put that about there, slide the heat shrink over the top, apply a bit of heat. There we go. And when you cut these off, just make sure that you haven't extended out the antenna beyond the end of the tie wrap. Like that. So that's all neatly tucked away. Do the same on the other side. So there we go, we've got both antennas nice and neatly mounted, and they will be clear of the props. And I think the only thing we need to do now is just replace this temporary vinyl tape with a couple of lengths of the proper cable tape. I like to use this because it's stronger and it's less sticky and goes less gloopy and horrible, and it's just got a nicer finish, and it does bind to itself really well. It's the sort of tape that you use for making cable harnesses in cars. I'll leave a link in the description where you can get hold of this. It's a little bit more expensive than the vinyl tape, but it's just nicer. Now the reason for using tape rather than tie wraps is the tie wraps do tend to dig into the cables, and it's just easier to get this off and put new pieces of tape on when you're in the field if you need to, basically. So the last thing we need to do is just to bolt down this top plate, and this is the real advantage of having the VTX and the antenna and pluggable by this cable on here. Is it's just a sort of like a sub-assembly, so it's much easier to get everything off. You don't have to leave things dangling out the side. But before we do that, we do actually need to put a battery strap on. Ooh, yeah. And when you put these on, make sure that the strap goes under the VTX antenna lead. You don't want to put any strain on that. Good. So all we need to do is, to finish this off, is plug that in. Make sure it's plugged all the way in, and then just locate the camera plates on the front here. Just give them a little nudge. There we go. And what we need to do is strap this down now. We're nearly done. The only things we've got left to do are configure this in BetaFlight and do a bit more setup on the radio, which will come in part 2, because this part 1 is really just the build and the minimum amount of software and transmitter setup. So there we go, all finished. Everything's wired up. We've got everything screwed into place and it's all looking good. Now just give it a quick visual once over, which is always a good thing to do. Make sure there's nothing loose, nothing where it shouldn't be. And this is a really nice little quad actually. I have to say the camera's very well protected at the front here. And there's plenty of room to mount a GoPro or Session or whatever you want on the front there. But what I'm going to do quickly is just go around and check that all hardware is tight. Always worth doing. Even if you get a ready to fly quad, don't assume that everything is correct. And also do an electrical check on it. Make sure there's no shorts across the terminals at the back. You can't check that you've not got shorts too often, because last thing you want is to blow anything up. See, it's all looking good. Don't need to be super tight, just nipped up so they don't come loose. People can get a bit too anal about this and end up putting Loctite and all sorts of things on here. I never bother. And just check the motors are nipped up nice and tight. All looking good. And there's great protection on these motors from the frame. This TBS Source frame, because it's open source, has had so many contributions from different people. It's a good, no-nonsense frame. You'll be able to get spare arms and body parts from pretty much anywhere. You could even cut your own if you've got the facilities, because the data, the plans for these are available all over the place. So there we've got it, everything built up, ready to go. All the hardware's nice and tight. We've done our electrical checks, so I can just plug a battery in safely, and that's making all the right noises with a good loud buzzer, which is excellent. We can see we've got some LEDs there. In part 2 I'll cover the final setup that we have to do on the radio and the configuration in BetaFlight. As always, thanks for watching. If you found that useful, give me a thumbs up and leave a comment. And if it's your first visit, then please consider subscribing to the channel for updates. I'll see you in part 2.